Organic compounds can undergo many different types of reactions. The types of reactions that each type of compound will undergo depends on the functional group that is present in it. Today, we are going to learn the 6 general types of organic reactions. In substitution reaction, one atom or a substituent or a functional group is replaced by another atom or another substituent or another functional group. Let me use these two equations to show you what it is a substitution reaction. In the first reaction, the hydrogen atom of an alkene molecule has been replaced by the bromine atom during the reaction. In the second equation, the bromine atom in the halogen alkane, upon undergoing reaction, has been replaced by a group of atoms. So this is the characteristic of a substitution reaction. Organic compounds that undergo addition reactions are usually unsaturated compounds. Unsaturated compounds are compounds that contains multiple bonds. An example of an unsaturated compound will be an alkene because it has a carbon-carbon double bond. Let's use the following example to show how addition reaction take place with an unsaturated compound as the reactant. In this reaction, where alkene react with bromine, the formation of the new bonds will take place at the carbon-carbon double bond. What actually happens is the pi bond in the carbon double bond will be broken. Then the two carbon atoms will form new bonds in the final product. This is the characteristic of an addition reaction. So you can see that two reactants actually come together, react, and form one single product. Elimination reaction, as the name suggests, involves the complete removal of a group of atoms from an organic molecule. Let's take a look at this example. In this example, water molecule has been removed from the organic molecule. Where are the atoms that make up the water molecules? If you look at the organic reactant over here, the water molecules come from the hydrogen atom over here, this oxygen atom over here, and this hydrogen atom. So during elimination reaction, the group of atoms that are to be removed must come from adjacent carbon. And when a group of atoms have been eliminated from the reactant, a CC double bond is formed in the organic product molecule. Condensation reaction usually involves the reaction of two organic compounds. At particle level, the two organic molecules will react and form one larger molecule with an elimination of a smaller molecule. It is very different from an addition reaction. Let's take a look at this example where we involve two organic molecules in the reaction. A hydrogen chloride molecule has been formed as the product. The hydrogen chloride molecule is formed as a result of breaking this OH bond in organic reactant 1 and the CCl bond in the second organic reactant. Then the remaining parts of the two molecules will then come together and form a new CO single bond in the final product. Oxidation reaction is a very special type of reaction. It involves the addition of oxygen atoms to the molecule or the removal of hydrogen atoms from the molecule. Certain organic compounds can undergo oxidation. One such example will be the alcohol homologous series. We will study them thoroughly when we come to the alcohol homologous series. For now, let's take a look at the characteristic of the organic reaction. Let's take a look at these two examples. In the first example, the alcohol molecule has been oxidized to a carboxylic acid functional group. In the second example, which is also another alcohol, it has been oxidized to a C double bond O functional group known as the ketone functional group. The type of organic product formed from oxidation reaction depends on the reactant that is being given. We will study them more thoroughly in the alcohol chapter. For now, what you need to realize is in oxidation reaction, other than forming the organic product, water is also formed as a byproduct. In the writing of the balanced chemical equation, for oxidation reaction, we will use this notation to represent the number of oxygen atoms that has been added in the oxidation reaction. In reduction reaction, the characteristic is very similar to oxidation, except we are adding hydrogen atoms to the molecule or removing oxygen atoms from the molecule. So in other words, it is the reverse of oxidation reaction. So how is it in a way a reverse of oxidation reaction? Earlier on, we have seen that alcohol compound can be oxidized to the carboxylic acid. So in this example, if you are given carboxylic acid as the reactant, it can be reduced to the alcohol. We will study more about oxidation and reduction when we come to the alcohol chapter. Now, that's the 6 different types of general reaction that you should be familiar with. Try the online quiz to see whether are you able to identify these 6 different types of reaction. Thank you for watching this video.